I'm Nick Craigwood. I'm CTO of Memset Limited, which is a small UK cloud provider doing cloud hosting and storage. And I'm here to talk about Rclone. Rclone is an open source command line program to transfer files to and from cloud storage providers. And it was started by me as a hobby in 2012 as a learning experience. I've always had a keen interest in data storage, so Rclone is very special to me. It's a passion project. I used to be a data hoarder. I used to have servers full of disks, and some of you might be like that too. But my wife complained about the noise and the electricity bill, so now I mostly keep my data in the cloud. So my talk this evening is going to start with a quick summary of Rclone and its history. I'll dive into how it works, show a bit of code. I'll discuss how you test a project like Rclone, and round off with a look of some of the favourite libraries used in Rclone. Before I get going, I just want to say, I don't want to give the impression that Rclone is all my work. I did start the project, but I've got a great group of people helping me. So I'd like to thank my excellent core developers, the super helpful group of people on the forum, and anyone who sent to PR or raised an issue. Rclone wouldn't be what it is today without you. Oh, and thank you for everyone who sent to PR correcting my spelling mistakes. So in summary, Rclone is a command line tool to sync your data to and from cloud providers. It takes a lot of care with data integrity, checking the hashes, preserving your timestamps. It can transfer data directly between cloud providers, so you can use it to back up your S3 objects to Google Cloud Storage, for instance. It has some optional features like encryption, but by and large, Rclone maps objects one-to-one from source to destination. Many of you will be familiar with rsync, which is, well, here's a slide I stole from Wikipedia. So Rclone syncing works very much like rsync. It transfers files, it synchronizes them, checking the timestamp and the size. It's commonly found on Unix systems. It works really well on Windows too, unlike rsync. The one thing it doesn't do is the rsync algorithm. So that is that really clever algorithm where rsync just transfers the changes. Now, unfortunately, that just isn't possible when trying to do that to cloud providers. They don't provide the API. And Rclone tries to keep that one-to-one mapping of your objects. So we could do it if we lost that mapping, but I really don't want to. So Rclone supports most major cloud providers. Well, I think so. They keep making new ones. But certainly all the big names are here. For business use, like S3, Google Cloud Storage, Azure, and personal use like Google Drive and Dropbox. There are also the standard protocols like FTP, SFTP, and HTTP. I particularly like the HTTP backend. You point it at a file listing web page, for instance the one like Apache generates, and it can pull the files off there recursively, or you can mount it like a disk. All Rclone operations are supported by all providers. So Rclone runs on a whole heap of platforms, thanks to Go's amazing cross-compiling abilities. So it's licensed under the very liberal MIT license, which means it gets bundled into all sorts of things, like Synology NAS and other products. Nearly all the platforms are cross-compiled on a Linux host as part of the Travis build, all except for Windows and macOS, which I had to build natively. So this is how Rclone came to be. So as I began to do less programming at work, I realized I needed to do some programming to keep my sanity. So in 2012, I decided to learn Go, as it just reached the exciting milestone of a 1.0 release. I made a few test programs, then I wrote my first major Go library, an interface with the OpenStack Swift object storage system. I needed a program to exercise that, so I wrote SwiftSync, which became Rclone in due course. So why Go? Well, there were some things that attracted me to Go immediately. We'd been using Python a lot at work, so the single binary for a deployment was just a breath of fresh air. Go excels in concurrency, which is really important for Rclone too. Everything works concurrently in Rclone, such as directory listings and transfers of objects. I started using Go as a new challenge, and it's really brought back the joy of programming for me personally. Lastly, Go is a really easy language to pick up, especially if you've done any programming in a language similar to C, such as Java. From its humble beginnings, Rclone has grown into quite a large project. As of today, we've got about 11,000 stars on GitHub, 200 contributors who've made 500 pull requests. Rclone gets downloaded 250,000 times a month, and it's been packaged by all the major Linux, Windows and Mac distributions. Exactly how Rclone got those users is a mystery to me, but being on the front page of Hacker News added about 1,000 GitHub stars overnight. Unfortunately, at that time, I was in the Outer Hebrides with no internet connection. So here's a visualization of the Rclone source code. That purple blob is me doing the source. We're in 2013 now, and you can see me adding some more cloud providers and renaming the project to Rclone. This is about when it got its first release. So nothing much happens for a little while. So you can see me making more cloud providers, making some docs. That's where that giant new branch appeared. And making more backends. Once you've got a framework for making backends, it's quite nice making new ones. So in 2015, something really important happened, which is coming up shortly, is Rclone gets his first contributor. So we've got 3 people working on the code now. And getting more backends. We implemented Amazon Cloud Drive at this moment, which was one of the things which made Rclone really popular, for reasons you'll find out in just a moment. And you can see the code growing. As the code grows, it gets refactored, puts in more directories, and yeah, there we go, adding an FTP backend, and NCDU, which I'll show you in a moment. And yeah, things are really heating up now. Look at all those developers all whizzing around. And when you see occasional big flashes of light, that's a release updating all the documentation. So we're into this year now, adding REST APIs, developers swarming all over the place, and yeah, major refactor, and we're about up to the present moment. So that's called a Gauss visualization, which I think is quite fun. So in 2017, I was surprised to find that Rclone was in the middle of a minor media storm, and this is how. In 2015, Amazon launched their unlimited drive storage product. You can imagine, for a certain kind of person that you can find on the data hoarder subreddit, this was a personal challenge. So the screenshot on the left was sent to me from that Reddit, and all the data, 1 whole petabyte of it, was uploaded with Rclone. Rclone was banned from Amazon Cloud Drive, probably as a consequence of this, although ostensibly it was the use of encrypted keys within the binary. Amazon also shut down the unlimited drive product in the US. I was surprised to have an interview with a journalist from the Register over this. Rclone's still banned from Amazon Cloud Drive, unless you have your own keys. I'll move on from the history to how it works. There are a number of different functionalities of Rclone. Each of these is implemented as a subcommand, otherwise known as a verb of the main program. You write the verbs after the command, so Rclone config or Rclone sync. More parameters can come after the verb. For data transfer, the main 3 verbs are sync, copy, and move. The first command you run after installing Rclone is Rclone config. This starts up the old school config wizard. I think I first saw this style of config wizard in Perl when configuring CPAN. It isn't the prettiest in the world, but it gets the job done. When it needs to do OAuth, it opens up your browser for you and redirects back to a local web server to receive the results. That's what it's doing at the moment. Anyway, I've got the token all ready to go. So we quit and do a little list. There we go, let's see what's in the drive. Stuff. So the next thing you're likely to do is to want to copy some files. Here's a quick demo of some files being copied using Rclone copy. So we list the remote, we copy some files in the source to the remote. Rclone doesn't say anything, it's a Unix program. If you want it to say something, use the V flag. And that worked fine. So sync, pretty similar, except the one thing sync does that copy doesn't is it will delete files off your destination. So at the end of a sync, the source and the destination look identical. So here we are doing the sync, and we list the remote with modification times now. And now we're going to change a few things locally. Remove a file, touch a file, modify a file, and then we'll do the sync again. Hope you appreciate my live coding abilities here. Actually, this is me typing, but I had a few practices to get this right. So, and there we see the source, and the sync and the destination is now identical. So, for those of you who prefer that in diagram format, on the left are the source and destination. On the left are before source and destination. On the right are the after source and destination. So they're the four things that can happen to a file. They can be copied, not touched, overwritten, or not touched in the case of copy. Whereas sync, files can be deleted in the destination. So if I just swap between the two slides, you can see that file 4 is being deleted in the sync. So that's enough of syncing for the moment. Here's another feature I really like. This is Rclone mount. You can mount any of the backends supported by Rclone, all 27 of them, as a fused filing system. It works on Windows, Mac and Linux. Rclone supports seeking the files, so you can play video quite well from them, and lots of people do that. If you want to open a file for both read and write, or seek while writing, then Rclone will need to download the file and work on a cached copy. That's because the cloud providers just don't provide the APIs for doing that sort of thing. Generally, the files you upload are immutable blobs. So this is now part of the VFS layer in Rclone, which adapts Rclone objects to work more like an actual file system. There you can see, that's my Google Photos on my Google Drive and some of the pictures. Lovely. So here's another one of my favourite features. It's a blatant rip-off, or homage as I prefer to call it, of the NCDU tool. If you've never used it, I recommend it. It's the best tool for answering the question, where's all my disk space? It lets you explore your local disk using a really easy to use Curtis interface. I had the idea of implementing this in Rclone, and I needed something to do on a plane journey, so hence Rclone NCDU was born. It uses the excellent termbox library to implement the text-based user interface. Now let's dive into a bit of code. So, as you might expect, Rclone implements its backends using interfaces. This shows the interface which all Rclone backends must fulfill. Rob Pike tells us, the bigger the interface, the weaker the abstraction. Alas, this is a big interface. It's broken down into 3 subparts in the Rclone source, but I presented the whole interface here, as it is, as all of it has to be implemented for a backend. You can see the kind of methods you might expect. List, new object, put, and make a directory. There are also some missing from the list, which I'll cover in a moment, like copy. So this is the interface a cloud storage object must fulfill. Again, pretty straightforward. Note the hash method, which you call with one of the types, the hashes method that the FS object returns. Open reads the object and update sets its contents. You can also read the modification time and set the modification time, something that's very important for Rclone syncing. All the backends support the interfaces in the previous 2 slides. However, some backends can do more, and Rclone can use that. For instance, the purge interface deletes a directory and everything under it. Some backends can do that, and some can't. So for instance, Google Drive can purge an entire directory, whereas on your local hard disk, you've got to delete all the individual files. So, for example, let's say you were doing a server-side move of an object. Some backends can do that immediately with the move method. For instance, Google Drive, you can rename something. Some support copy, but not move. For example, S3, you can copy an S3 object, but you can't rename it. Rclone will copy the object and then delete it if you want to move it. And some don't support either. For instance, B2. All the objects are immutable. In which case, Rclone will download the object and upload it again. Here's how you might use those optional interfaces with a type assertion. That's straightforward Go code. However, Rclone backends can wrap other backends. For example, the encryption backend wraps any of the other backends and encrypts the data. So the outer backend wants to expose what the inner backend can do. So it must implement all the optional methods. The inner backends may not implement all of the optional methods, so we've got a problem. The traditional solution to this is a sentinel error, which we check. Here we call purge and check the error value against rclone purge. This works very well, provided you don't want to know which methods are used in advance. Unfortunately, Rclone needs to know what the capabilities of the backends are before it starts doing things. So the solution to that is a good old struct full of function pointers. This is filled in with a bit of reflection, so it doesn't take any manual work to keep it up to date. Backends which wrap other backends, logical and their own features of wrapped backends to make the final feature struct. To use purge, say, you just check to see if the pointer is nil. If it isn't nil, that means the method is supported, so you can call it. Those of you who've used C++ will realise this is a re-implementation of the V-table or virtual table. Go made the implementation straightforward there. So let's go into Rclone, let's go into how Rclone is tested. As you saw earlier, Rclone supports a lot of providers. There's lots of commands, architectures, OSs. That makes it really hard to test. So hands up anyone who would enjoy writing mocks for 27 different cloud providers. No, I didn't think so. So Rclone does a lot of integration tests. These give confidence that Rclone works properly, keeps on working. After all, cloud providers change too. So Rclone has a full continuous integration pipeline. I think we're amazingly lucky as open source developers to be able to use GitHub, Travis and AppVeyor for free. They're fantastic tools. The CI tests run all the non-integration tests and build binaries for all the platforms, uploading them for beta releases automatically for every branch pushed to the main repository. The integration tests run on a separate server. These run the tests, which are just normal Go unit tests with some extra flags against all the backends. Running these tests costs money and takes a long time, as in 30p and an hour or two. So I don't run them against every pull request, only against the master branch and only once per day. The integration tests produce a report for the developers to look at. This was a good day, with only one failure out of 105 tests. Often there are lots of failures, usually because some cloud provider glitch, but sometimes because we generally broke something. Making a pretty report like this, well, that's pretty by my standards, wasn't high on my priority list. However, I completely messed up one of the releases by misreading the old report. So I made a report which I couldn't misunderstand. The integration tests Rclone uses a standard Go test. It's easy to add flags to the Go test, and Rclone adds a remote flag to tell it to run the test against an actual backend. Unlike unit tests, integration tests often fail. The internet's a messy place, things go wrong. So Rclone's test all framework reruns the tests that fail to try and get them to pass. So as you can see in the grey boxes, attempt 1 out of 5 runs it with no parameters, attempt 2 out of 5 runs it with tests run with the two tests which did fail. I should probably take the time to open source this, as it could be useful. In Go 1.6, the concept of nested tests was introduced. this made Rclone's life much easier. As you can see, it's only a few lines of code to run the integration test suite for a backend. Some backends run the suite more than once with different parameters. When making a new backend, you can use the integration tests as a guide for what you need to work on next, and it makes the process quite enjoyable. Pre-Go 1.6, code generation was used to make the integration tests, which was rather painful. So thanks to the Go team for making nested tests. So this is something that maybe you don't know, but you can make your life a lot easier. You can add flags to tests. You don't need to do anything special, just define flags with the standard library flag package. There are some great examples of this in the standard library, for instance using a golden flag to make the test files. Rclone uses the flag to indicate these tests should run with a real backend to help debug those tests. Rclone's a reasonably large program now, approaching 100,000 lines of Go code. However, it's built on a fantastic set of libraries, some of which I'll talk about in a moment. And all of that in turn is built on the Go standard library. Rclone uses the vendor directory to keep that all straight, and we recently switched to Go mod to manage that. I don't think we can drop the vendor directory just yet, as Rclone needs to support old Go versions for Linux distros that package Rclone, maybe in a year or two. I'll just run through a few of my favourite libraries and tools that Rclone uses. There are loads of other libraries I could have mentioned here, so apologies to any authors I've missed out. My first choice is Go imports, which Jake mentioned earlier. Install it in your editor and never type in import statement again. I think it's fantastic. It's my #1 productivity tool. So here we are running Go imports, import some more things. Maybe you've all seen it already, but if you haven't, install it. That's me doing it Emacs. It works in Vim too. So Rclone's a pretty heavy-duty command line program, and if you're making one of those, you want to use Cobra. Cobra is excellent for organising command line programs with lots of verbs. You can see Rclone's verbs down the right-hand side. I'm sure many of you use kubectl or Docker. Those are both written with Cobra. Cobra comes with a flag library, pflag, which allows you to create POSIX flags. Flags made by the Go library are somewhat old school in comparison. Cobra also creates your bash completion script for all those people like me who use bash but hate writing bash scripts. Cobra helps with the docs too. When you write a command, Cobra makes command help for it and then has a really way of turning that into Markdown for the website. So on the left we have the code. In the middle, that's when you run Rclone with -h, and on the right is the website. So a lot of the help on the website was generated this way, and it helps keep everything nice and consistent. I then use pandoc to turn the Markdown into a man page, and one big HTML file for the download, for the Windows users mostly. So if you've been keeping up with the Go news, you've all have read the errors proposal for Go 2. pkg/errors package was one of the motivations for the proposal, so I imagine at some time I will be retiring it. Use it to annotate your errors as they bubble up through your code. This means that rather receiving a log message with unexpected EOF, in fact we saw one of those earlier today, didn't we? Nice EOF log message. You receive a helpful message which gives you some idea as to what really went wrong. I can usually rely on Rclone users to send me a log message. So I'm just going to talk briefly about what to do if your open source package takes off. It's easy to get daunted by hundreds of issues, most of which are support requests. So the first thing to do is open a forum and get the users helping themselves. I use Discourse. It's free and easy to set up and maintain. Don't be shy of asking users who make issues for help. They've got a problem, they want to help. I've had many contributions from Rclone from people who've made an issue, and I say, would you like to help with that? And they say, well, I don't know Go, but I'll have a go. So you might need to give a bit of a helping hand, but that's a positive process for both parties. So when you've had a few good pull requests from someone, you can recruit them as a developer. Oh yeah, write lots of docs, contributing docs, so on and so forth. On the right there, you can see Rclone star history. You can see in the middle of 2016, it went on the front page of Hacker News, and see what happened to the star chart graph. So yeah, if you've got a project you want to make popular, get it on the front page of Hacker News. I have no idea how you do that. I have no idea who posted it, but anyway. So finally, rather than managing hundreds of emails from GitHub, use octobox.io. I think it's a fantastic tool. It's really good at managing those notifications for you. It made my life so much easier. So rather than looking at all those emails. Right, and that's it. Thank you very much.